Chapter 2 Mortars. Mortar is an intimate mixture of binding material, fine aggregate, and water. When water is added to the dry mixture of binding material and the inert material, binding material develops the property that binds not only the inert material but also the surrounding stones and bricks. If the cement is the binding material, then the mortar is known as cement mortar. Other mortars commonly used are lime mortar and mud mortar. The inert material used is sand. In this chapter, first an introduction is given to the inert material sand, and then the proportioning, mixing, curing, properties and uses of different mortars is explained. At the end of the chapter, various tests conducted on mortars is presented. 2.1 Sand. Sand is a natural product which is obtained as river sand, nulla sand, and pit sand. However, sea sand should not be used for the following reasons. 1. It contains salt and hence structure will remain damp. The mortar is affected by efflorescence and blisters appear. 2. It contains shells and other organic matter, which decompose after some time, reducing the life of the mortar. Sand may be obtained artificially by crushing hard stones. Usually artificial sand is obtained as a byproduct while crushing stones to get jelly, coarse aggregate. Sand is used in mortar and concrete for the following purpose. 1. It subdivides the paste of binding material into thin films and allows it to adhere and spread. 2. It fills up the gap between the building blocks and spreads the binding material. 3. It adds to the density of the mortar. 4. It prevents the shrinkage of the cementing material. 5. It allows carbon dioxide from the atmosphere to reach some depth and thereby improve setting power. 6. The cost of cementing material per unit volume is reduced as this low-cost material increases the volume of mortar. Basic civil engineering. 7. Silica of sand contributes to formation of silicates resulting into the hardened mass. The properties of good sand are: 1. It should be chemically inert. 2. It should be free from organic or vegetable matter. 3. It should be free from salt. 4. It should contain sharp, angular, and coarse grains. 5. It should be well graded. 6. It should be hard. 2.2 Cement mortar. For preparing mortar, first a mixture of cement and sand is made thoroughly, mixing them in dry condition. Water is gradually added and mixed with shovels. The cement to sand proportion recommended for various works is as shown is Table 2.1. Table 2.1. Cement to sand proportions for various works No. Works: cement, sand 1 2 3 4. Masonry works: plastering masonry, plastering concrete. Pointing 1:6 to 1:8 1:3 to 1:4 1:3 1:2 to 1:3. Curing cement gains the strength gradually with hydration. Hence it is necessary to see that mortar is wet till hydration has taken place. The process to ensure sufficient moisture for hydration after laying mortar/concrete is called curing. Curing is ensured by spraying water. Curing normally starts 6 to 24 hours after mortar is used. It may be noted that in the initial period water requirement is more for hydration and gradually it reduces. Curing is recommended for 28 days. Properties of cement mortar. The following are the important properties of cement mortar. 1. When water is added to the dry mixture of cement and sand, hydration of cement starts and it binds sand particles and also the surrounding surfaces of masonry and concrete. 2. A mix richer than 1:3 is prone to shrinkage. 3. Well-proportioned mortar provides impervious surface. 4. Leaner mix is not capable of closing the voids in sand and hence the plastered surface is porous. 5. The strength of mortar depends upon the proportion of cement and sand. Strengths obtained with various proportion of cement and sand is shown in Table 2.2. Mortars 35 Table 2.2 No. Cement sand compressive strength 1 2 3 4 5 1 3 1 4 1 5 1 6 1 8 10 n/mm2 7.5 n/mm2 5.0 n/mm2 3.0 n/mm2 0.7 n/mm2 Uses of cement mortar. Mortar is used 1. To bind masonry units like stone, bricks, cement blocks. 2. To plaster slab and walls, make them impervious. 3. To give neat finishing to walls and concrete works. 4. For pointing masonry joints. 5. For preparing building blocks. 6. As a filler material in ferro cement works. 7. To fill joints and cracks in walls. 8. As a filler material in stone masonry. 2.3 Lime mortar. Fat lime and hydraulic limes are used for making lime mortar. If fat lime is used, sand mixed is normally 2 to 3 times its volume. If hydraulic lime is used, sand mixed is only 2 times the volume of lime. Lime is prepared by pounding, if quantity required is small, or by grinding, if the required quantity is more. Pounding. For pounding, pits are formed in hard grands. The size of pit is usually 1.80 m long, 0.4 m wide and 0.5 m deep. It is provided with lining of bricks or stones. Lime and sand dry mixed with required proportion is placed in the pit. Small quantity of water is added at intervals. In each interval the mix is pounded with wooden pounders and mortar is turned up and down. The process is continued till uniform color and desired consistency is achieved. Grinding. This is the better way of getting good mix. The grinding may be carried out in bullock-driven grinding mill or in power-driven grinding mill. Figure 2.1 shows a typical bullock-driven grinding mill. It consists of a circular trench of radius 3 to 4.5 m, 0.3 m wide and 0.4 m deep. A wooden shaft pivoted at center carries a stone wheel of width just 50 mm to 100 mm less than that of trench. Bullock drive this wheel in the trench for grinding mortar. The dry mix is placed in the trench. Water is added gradually and bullock-driven stone wheels grind the mix. A worker turns the mix up and down regularly. This method of preparing mortar needs 6 hours and can produce about 1.7 m3 of mortar. Basic civil engineering. Bullock to be attached at this end, stone wheel shaft pivot mortar GL circular trench. Fig 2.1. Bullock driven grinding mill. Figure 2.2 shows a typical power driven grinding mill used for preparing lime mortar. 2 rollers rotate in a pan of diameter 1.8 to 2.4 m. Either pan or roller is rotated with the help of oil engine or electric power. During mixing, required quantity of water is added gradually. Driving pulley steel pan plus stone rollers frame. Fig 2.2. Power driven grinding mill. Lime mortar is also having good grinding property. Fat lime mortar is used for plastering while hydraulic lime mortar is used for masonry construction. This mortar was considered cheap in olden days and was commonly used in small towns. However, the cumbersome process of preparation and ease in availability of cement in market has almost replaced the use of lime mortar. 2.4 Mud mortar. Clay lumps are collected and are wetted with water and allowed to mature for 1 or 2 days. It is kneaded well until it attains required consistency. Sometimes fibrous materials like gobber is added in the mix. It prevents cracks in the plaster. If plaster is to be used for outer walls, it is sprayed or painted with bitumen. It is cheap mortar. Its durability is less. It is normally used for the construction of temporary sheds and cheap houses in rural areas. Mortars 37 2.5 Special mortar. The following are some of the special mortars: 1 cement clay mortar, 2 gauged mortar, 3 decorative mortar. 1. Cement clay mortar. Quality of clay mortar can be improved by adding cement to the mix. Normal proportion of clay to cement is 1:1. It maintains the economy to some extent and there is sufficient improvements in the durability of mud mortar. 2. Gauged mortar. It is the mortar obtained by adding cement to lime mortar. The usual proportion of cement, lime, and sand are 1:1:6, 1:2:9 and 1:3:12. This mortar is to be used within half an hour after mixing cement. Obviously, it is cheaper than cement mortar and its quality is between that of cement mortar and lime mortar. 3. Decorative mortar. These mortars are obtained by using colored cement. They are used to give pleasant appearance to outer walls. 2.6 Tests on mortar. The following tests are conducted on the prepared mortars to ensure their quality. 1. Crushing test. 2. Tensile strength test. 3. Adhesive test. 1. Crushing test. This test is carried out on a brickwork with the mortar. This brickwork is crushed in a compression testing machine and the load is noted down. Then the crushing strength is obtained as load divided by cross-sectional area. 2. Tensile strength test. The mortar prepared is placed in a mold of briquette which has central cross-sectional area as 38 mm x 38 mm. After curing, the briquette Fig 2.3 is pulled under the grips of tensile testing machine. The ultimate load 38 mm noted. Then the tensile strength of mortar is load divided by the central cross-sectional area. 3. Adhesive test. 2 bricks are joined together with mortar to be tested as shown in Fig 2.4. The upper brick is elevation 76 mm suspended from an overhead support. A board is hung from the lower brick. Then weights are added to the board till the bricks separate. The adhesive strength is the load divided by area of contact. 38 mm 152 mm Plan Fig 2.3. Briquette for tensile test. Civil engineering mortar joint suspender weights 190 90 90 90 91 90 elevation side view plan Fig 2.4. Adhesiveness test arrangement questions 1. YC